Hello, my beautiful viewers. We are welcome to a new section of the indefinite integral we'll be treating. Okay, so in today's video, we'll be checking a very important concept in indefinite integral, which is integration by parts. Okay, so if you are new to this channel, please don't forget to check our previous videos on indefinite integrals. Okay, make sure you watch, like, comment, and share to your friends too. All right, so in today's video we have integration by parts. Okay, so we have given two functions v of x and then u of x, then integral u dv is equal to uv minus integral v du. Then how do we prove this? So after the proof, I'm going to do like 3 examples as usual, so that we can explain, we can understand this integration by parts very well. Now let's start the proof. All right, so recall from product rule. All right, recall from product rule. You know, we have two functions, u of x and v of x. Then if you differentiate their products, that is, if you differentiate u of x, v of x with respect to x, so this will surely give you u of x, then multiply by the derivative of vx, which is the v over the x, then plus v of x, then multiply by the derivative of u of x, which is the u over dx. All right, so the next thing we are going to do now is to integrate both sides with respect to x. So we have integral dx, integral dx, then integral dx. All right, moving on. So we are going to have this, if you integrate this will surely give you u of x, v of x. All right, then if you integrate this will surely give us u of x dv. Then if we integrate this will give us v of x du. Okay, but how do we make this guy the subject of the formula? So you can just bring u of x, v of x to the right hand side and bring integral ux dv to the left hand side. So we have integral u of x dv, which is equal to, if you bring this back to this, we're going to have u of x, v of x, then minus integral of v of x du. All right, so that's how we derive that very important formula. Okay, so let's do like 3 examples. All right, so example 1. So let's say we want to integrate x multiplied by sine x dx. So we can see x is a function, sine x is another function. So we are integrating product of two functions. So the best method we can use here is what? The integration by part method. So that is the best method we are going to use. Okay, so the first thing is to know your u and your dv. So I will be using x as our u. Y is very easy and straightforward to differentiate. Then we're going to use sine x as our dv. Okay, so we have u to be x. Then the next thing you are going to do is to find the u, that is, you differentiate, and then if you do that we have 1. Then next thing, sine x, which is our dv is equal to sine x. So for us to find v, we have to integrate. So if you integrate sine x, you have minus cos x. Okay, then you apply this formula we just derived. Okay, so we have integral of ux dv, that is x multiplied by sine x, integral of x multiplied by sine x will be equal to, sorry, I forgot to put the x, will be equal to u of x, v of x. What's our u of x, which is x? What's our v of x, which is minus cos x? So we have minus x cos x, then minus integral of v of x, that is this guy, which is minus cos x dx. So minus times minus will give us plus. So we have minus x cos x, then plus integral of cos x dx. Then if you integrate cos x, that will give us sine x. We have minus x cos x plus sine x, then everything plus c. All right, but if you don't want to do it this way, we have a very short method that we can use to solve this beautiful problem. So if you don't want to use this method, so the function is x multiplied by sine x dx. Okay, so we have our u, then we have our dv. So our u, as I've said earlier, is x, then our dv is sine x. Okay, so we call this plus. Then if we differentiate x, we have 1, we call this minus. Then if we differentiate 1, we have 0, we have plus. If we integrate sine x, we have minus cos x. Then if you integrate minus cos x, you still have what? Minus sine x. Okay, so next thing is to multiply. So x will multiply by minus cos x, then minus 1 multiply minus sine x. So x multiplied by minus cos x will give us minus x cos x. Then minus 1 multiplied by minus sine x will give us plus sine x, then everything plus c. It's very easy and straightforward, right? Yeah, it's very easy and straightforward. So let's do the second example. Example number 2. So we have integral x multiplied by, let me use x cube, then e raised to the power of 2x dx. Okay, I'll be using the second method so that we are not going to waste much of our time. Okay, so using the second method, my u will be x cubed, very easy to differentiate. Then my dv will be e raised to the power of 2x. Okay, so don't forget plus. Then if we differentiate, we have minus 3x squared. Then if we differentiate again, you put plus, we have 6x. If you differentiate again, we put minus, we have 6. Then if we differentiate again, we put plus, we have 0. If we integrate e raised to the power of 2x, remember, integral of e raised to the power of ax dx will surely give us 1 over e, then e raised to the power of ex plus c. So if we integrate e raised to the power of 2x, that will give you 1 over 2 e raised to the power of 2x. If you integrate again, 1 over 4 e raised to the power of 2x. If you integrate again, 1 over 8 e raised to the power of 2x. And if we integrate again, 1 over 16 e raised to the power of 2x. Then you do the same thing we did earlier. This guy and this guy will multiply each other. Alright. So x cubed multiplied by 1 over 2 e raised to the power of 2x. We have 1 over 2 x cubed e raised to the power of 2x. The second one, minus 3 over 4 x squared e raised to the power of 2x. The third one, plus 6 over 8 x e raised to the power of 2x. And the last one, minus 6 over 16 e raised to the power of 2x, then everything plus c. So we can simplify this completely. We have 1 over 2 x cubed e raised to the power of 2x, then minus 3 over 4 x squared e raised to the power of 2x, then 6 over 8 will surely give us 3 over 4. So we have 3 over 4 x e raised to the power of 2x, then minus 6 over 16. That will surely give us 3 over 8 e raised to the power of 2x plus c. Very easy and straightforward. In this particular integration by parts, maybe in my coming videos, I'm going to explain some very important stuff, how to integrate some add functions using this particular method. Okay, but not today. Next class or in our future videos, you're going to see there. All right, and the third example, let me just say the last example for today. So example number 3. So we have integral of let's use natural log of x multiplied by x raised to the power of 3 dx. Yeah, this is very beautiful. So what I'll be asking you now is that which one are we differentiating and which one are we integrating? Is it x cubed we are differentiating or ln x? Which one? Just stuck. Okay, yeah, you are saying we should differentiate ln x and integrate x cubed. Yeah, that's good. U then dv. So let's differentiate ln x and then let's integrate x cubed. Okay, so if we differentiate ln x, we have 1 over x. Then if we integrate x cubed, we have 3. I mean, rather, x raised to the power of 4 over 4, sorry. X to the power of 4 over 4, then you multiply. Right, so ln x multiplied by x to the power of 4 over 4, we have 1 over 4, x raised to the power of 4, ln x, then minus, don't forget uv, using the formula uv, then minus v the u, that is minus integral of x raised to the power of 4 over 4 multiplied by 1 over x dx. All right, so we can see x, we cancel one x here, then we can also bring out the constant. So we have 1 over 4 x raised to the power of 4 ln x. Where do we see 1? Oh yeah, this 1 over 4 here. Then minus 1 over 4 integral x cubed dx. So if we integrate x cubed, that will give x raised to the power of 4 over 4. So the final answer is 1 over 4 x raised to the power of 4 ln x, then minus, x cubed. With the integrity, you have x raised to the power of 4 over 4. 4 multiplied by 4 will give you 16. You have 1 over 16 x raised to the power of 4, then everything plus c. So that is about that. So that will be the end of our today's video. Okay, so if you like this kind of video, please don't forget to subscribe, like, comment, then I'll also share. Thanks for watching. See you next time. Goodbye.